Anyways, people, today what we're going to do is we are going to look at angles and parallel lines. So in order to do this, first of all, let's think about lines and how we often define them. So if we were to take a straight line, and if we were to consider 2 points on it, so let's label a point here, and we'll just call this A, and let's label another point down here. We'll call this point B. The way we would name this line is we would call this line A, B, because it's got the letter A and the B on there, and it makes it really easy to identify what line we're talking about as part of that. Now, if we were to add another line to this, let's add this line here. Okay, now with this line here, we could name this as well. So let's call this one, we've already used A and B, so let's use C and D. So we've also got line CD. Now, what's happening here is these two lines are intersecting, and when they're intersecting, it's just where they come together at a point, and they may cross over as well. So as a part of that, then we could also label another part of this. Let's label that center part here. So this part right here, we could label this E, just to denote where they cross over as part of it. So using letters is an important way to understand all the different parts of lines and where they're coming and going from. Now, what we're going to consider is a special characteristic of lines. Now, we've got two sets of lines here. We've got one set which I've drawn in blue and the other set which I've drawn in the purple aspect here. Now, when we consider the purple lines, if we were to consider the distance between them, the distance down here between the two lines is much greater than it is at this point here. So there is some point, if we were to continue on in this direction, these lines would meet and they would intersect at some stage. Okay, so in this case here, this is an example of what's not a parallel line. So what we can do, we can erase this as we don't really need this anymore. But what we do have down here with these blue lines, if we were to continue on forever, by the looks of it here, the distance between the 2 points here and here at the bottom, the distance between the points here and here at the top, they appear to have the same distance between them. And if we were to continue on further and further and further, based on what I see here, I would expect that to continue on, and where they have that identity of being the same distance apart at all times. So when you have that property, what you have is some parallel lines. And in particular for parallel lines, what we tend to do is we tend to put these arrows on it, just like this, and these arrows indicate these lines are parallel. Now, with these lines, if we were to add some letters to it, so in this case here, let's use Q, P, R, and S. Okay, now what we're doing here or seeking to do is I'm seeking to just label these lines here so that I can identify them. Now, as a result, if I do want to make a comment on these, that these are parallel, a way I can go about this is I can use some words. So in this case here, I could say RS is parallel to PQ. Okay, and that could be one way I do it. But if I want to go further than this, another way I can go about this is I can change these parallel part to a certain symbol that we tend to use. That symbol we tend to use is where we've got two lines vertically like this, which are more or less parallel themselves to represent that. So another way I could do this is RS, and so this symbol here with those two lines like that might make mine a bit bigger, so it's clear they're not like ones or the number 11. So RS is parallel to PQ. And that's another way of denoting it. That's just the symbol that we use when we're trying to state that we have parallel lines. Now, another key aspect to consider when we're dealing with lines is perpendicular lines, because often they come in relation to parallel lines. Now, perpendicular lines are special. They're special in this sense because, well, they're not parallel, but they do have that idea of crossing over here. So they do cross over, but when they do cross over, the special thing about them is they do this. As you can see here, it's like crossing over perfectly. They do this at right angles. So this angle here is 90 degrees. So perpendicular lines always intersect at 90 degrees. So if I was to put some letters on this, let's use T, X, Y, and Z. Okay, now based on this, I've labeled each of these lines here. We can make a statement, just like we do with the parallel lines. If we did that here, we could say that TX is perpendicular to YZ, but instead of writing is perpendicular to, what I want to do is I want to have a way of shrinking this down. So the way I'm going to go about this is I'm going to write TX, and this time the symbol I'm using looks like perpendicular lines. So it's got the one line going down and then one going sideways to represent the perpendicularity of it. And so that symbol there is just representing is perpendicular to, and I can write YZ on the other side. And this is another way of shrinking it down and stating that lines are perpendicular.